Our lesson today is to be able to use proportions to find the missing side of similar figures. There are two characteristics that have to be in place in order for figures to be similar. When two figures are similar, their corresponding angles are congruent. Right? So B is congruent to E, A and D are congruent, C and E are congruent. Corresponding angles are congruent. Corresponding sides must be proportional. So those are the two characteristics that have to be in place in order for figures to be similar. So we use those characteristics to test to see or determine when figures are similar or not. Okay, so let's take a look at these two figures. Question asks us, or these three figures, we're asked which rectangle is similar to rectangle A. Well, let's check A and B. Right, is 3 to 6 the same as 2 to 6? Right, are the ratios of the corresponding sides the same? Is 3 to 6 the same as 2 to 6? Right, and what we do is we use what's called the cross products property. So first I write the ratios of the corresponding sides, and I want to see if they're equal. So I check the cross products. Is 6 times 2, which is 12, the same as 3 times 6, which is 18? The answer to that is no. So according to the cross products property, which says that the cross products are equal when the figures are similar, right? So they don't equal here. Well, let's try A with C. Is 3 to 6 the same as 2 to 4? Let's check those cross products. 6 times 2 is 12. 3 times 4 is 12. We could see that those cross products are equal, which means that rectangle A and rectangle C are similar because the corresponding sides are proportional, and we can see that because the cross products property tells us so. All right. Next question asks us, rectangle D is 3 by 1. Which rectangle is rectangle D similar to? Well, 3 units long, 1 unit wide. Well, what's 1 by 3? Well, 1 by 3 is the same as what? This one here that we found, right? Because 2 over 6 is the same as 1 over 3. So because 2 over 6 is the same as 1 over 3, right, I know that these two would be equal, so it would be rectangle D and rectangle B. We continue. So we want to use that cross products property to write proportions to find the missing sides of similar figures. So we're told two triangles are similar, the corresponding side lengths are proportional. We can write in solid proportions to find the missing side. So there are a couple of different proportions that we can write. We can write a proportion within the figure or write a proportion between the figures. Let's try within the figure first. 6 to 8 is the same, so I have to write a ratio of this side to this side. That would be a ratio of 9 to x. When we cross multiply and divide, 6 times x is 6x, 9 times 8 is 72. When we divide both sides by 6, we wind up with x is equal to 12. Alright, but I can also write my proportion this way. Alright, between the two, I could write 6 to 9 is equivalent to 8 to x. Cross multiply, 8 times 9 is 72, 6 times x is 6x. And you can see that I get the same cross products for both ways. Divide both sides by 6, divide by 6, they cancel. Alright, and we get 12 is equal to x. Alright, so let's continue. So we want to use that cross products property in proportions to find the missing side of similar figures. I can set my proportions up a couple different ways, but let's do it this way. If I write the ratio as 6 to x, that would be long side to short side. The corresponding proportion would be 9 to 6. I cross multiply. 9 times x is 9x. 6 times 6 is 36. That's my cross product. Divide both sides by 9. X has to be equal to 4, because 36 divided by 9 is going to be equal to 4. Okay, let's try this next one here. If I write, let's see, what do? We did within there. Let's do between. So if I do 14 to 7, that would have to be then the corresponding ratio would be x to 12. We cross multiply. 7 times x is 7x. What's 14 times 12? Well, 14 times 10 is 140. 140 plus another 28. That's 168. And when we divide by 7, we divide by 7. 7's cancel. X is equal to, what's that, 24? X would be equal to 24. These are centimeters, of course. Okay, so let's try these problems here. Which parallelogram is similar to parallelogram A? Right, well, let's see. We have parallelogram A, parallelogram B, parallelogram C. We want to find out which one's similar to A. Let's write our proportions. Right, is 8 to 12 the same as 4 to 6? We use that cross products property. Let's see, is 8 to 12? Yes. So 6 times 8 is 48. 12 times 4 is 48. So it looks like, right, these two are similar. Well, let's just check, right, make sure this one should not be similar. So I'll check it with the 4 to 6 one. Is 4 to 6 the same as 6 to 12? Check their cross products. 4 times 12 is 48. 6 times 6 is 36, right? And those cross products aren't equal. So I know that the parallelogram C is not similar to either parallelogram A or B. Okay, let's try our triangles. Let's do 8 to 4. Right, if I use 8 to 4, is that the same as x to 6? Cross multiply. 6 times 8 is 48. 4 times x is 4x. When we divide both sides by 4, x is going to be equal to 12 here. Right, and we see that, right, because 8 is 2 times 4, 12 is 2 times 6. All right. Next example. An artist draws a replica of a painting that's on the Berlin Wall. The painting includes a red trapezoid. The shorter base of the similar trapezoid in a replica is 3.75 inches. What is the height, h, of the trapezoid in the replica? Okay, so let's write our proportion. Right, 12 over h. If I write that ratio, 12 to h, then I'd have to write 15. What is that? 15 over 3 point, what is that? 75. When we find our cross products, right, 15 times h, we know that 15 times h is what? 15h. And then we have to multiply 12 times 3.75. Right, so what is 12 times 3.75? That's going to be 45. And then when we divide both sides by 15, right, they cancel. H is going to be equal to 3. Right, so the height in inches of the replica, right, that's going to be 3 inches. All right, now let's move on to these problems. I thought these were pretty neat, so let's give them a shot. Right, we want to know if these figures are similar, but we're not given any dimensions at all. So if the figures are drawn on grid paper, it's up to us to find the dimensions first. So this is 3, this is 2, 4, that's 5. This is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10. Oops. So is 3 to 5 the same as 6 to 10? I think we all know that the answer is yes. When we check the cross products though, 10 times 3 is 30. 6 times 5 is 30. Right? So that would be a yes because the cross products are the same. Right? A little bit different with quadrilaterals, right? We need a few different measurements here. This is 3 units, 2, 4. That's 5 units. This is 2, 4. That's 5 units. This is 2. This is 4. And this is 4. Well, we can see already that, well, let's try. Is 5 to 5 the same as 4 to 4? Well, we know that that's yes, right? Because 5 over 5 is 1, 4 to 4 is 1. But what about this ratio here? Is 3 to 5 the same as 2 to 4? Check those cross products. We get 3 times 4 is 12. 2 times 5 is 10. And the answer to that would be no. Right? So even though these sides are proportional, these sides must also be proportional, and they're not. Alright? Last couple of problems here. Right? We have, this is 2, this is 1, 2, 3, 4. It's 2 by 5. This is 3 by 1, 2, 3, 4, 5, 6, 7. And let's see, is 2 to 5 the same as 3 to 7? Right? Cross products, 2 times 7 is 14, 3 times 5 is 15. The answer to that would be a no. And our last one here, we have 3 to 3. This is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. Right? Is 3 to 3 the same as 6 to 6? And we know the answer to that is yes, because when we check the cross products, 18 is the same as 18. Alright? So just to wrap that up, we know that we can use, we know that there are two characteristics that must be in place in order for figures to be similar. We know that the corresponding sides must be proportional, and we know the corresponding angles must be congruent. The fact that the corresponding sides must be proportional means that we can use proportions to find the missing sides of similar figures. So we set up a proportion, we use our cross products property, which says that the cross products of two equivalent ratios will be the same. So when we solve a proportion, we do two steps. We cross multiply, we divide. All right, I hope that's been helpful, and we'll see you soon.